27. Right rectangular prism X is similar to right rectangular prism Y. The surface area of right rectangular prism X is 58 square centimeters, and the surface area of right rectangular prism Y is 1,450 square centimeters. The volume of right rectangular prism Y is 1,250 cubic centimeters. What is the sum of the volumes in cubic centimeters of right rectangular prism X and right rectangular prism Y? Okay. So, here is how I approach this. Well, first off, we should establish what a right rectangular prism is. A rectangular prism is just, like an extended, like a cube that's been stretched. And we say a right one means it's a right angle. And if you drew a line straight down and make a right angle to the floor. You don't normally see these in high school math books, but if you slanted it like this, then it would be an oblique rectangular prism. And you just don't see those. But right rectangular prism is the correct one. So, okay, so we have two right rectangular prisms, X and Y. X is way smaller, but they're similar. They're proportional. So if we blow up X or shrink Y, we can make them be the exact same size. So we have X, which is a little baby prism. Boop, boop, boop. And then we have Y, which is way bigger. Not drawn to scale, not drawn super accurately, but just to have a visual. Okay, so the surface area of the right rectangular prism X is 58 square centimeters. And Y is 1,450 square centimeters. Now we don't know the volume of X. We do know the volume of Y. So this is our surface area. I'm just going to use area. That abbreviation has taken on other connotations in recent years. So we're just going to use A for area. And then V for the volume. We don't know that one. V for volume over here is 1,250 cubic centimeters. Now, just the lengths of the sides, which we cannot determine. I don't think we can. I'm trying to think, is there a way you could? With time and a lot of patience, yeah, I think you could, but not easily from what we're given or very quickly. That's not how we're going to solve this. We're not going to solve this by trying to figure out what the lengths of the sides are of these two rectangles. That's not the right way forward. It's not the quickest, the easiest, not the way it's going to get you this answer in the time allotted. So, if we were just looking at a side, a length of a side, there'd be a ratio between X and Y. Like this side to this side would have the same ratio as this side to that side. Whatever that ratio is. That ratio is going to be, I'm going to call it K. It's a constant. Now, the ratio of the area to one or the other, because everything is squared, then the ratio is, that constant is going to be squared. Now the volume, the constant, is going to be cubed because you're multiplying things. So you want to get back to that original ratio is how I view it. So for me, the way I did that is the constant, the ratio is squared for the area and it's cubed for the volume. And I want to get this to be comparing apples to apples where it's the same constant. The constant is equal to a constant. I want to say the constant, that's when compare the area is going to be equal to a constant we compare with the volume. But this ratio is when it's squared and this ratio is when it's cubed. So how do I do that? I'm going to take the square root and the cube root. Right, so first for the areas, the surface areas, the square root of 58, that surface area of X, to the square root of Y, 1,450. That is the initial constant ratio because I'm taking the square root. On the volume, the cube root of the 1,250 and the cube root of the volume of X, which is what I'm trying to find because I need to be able to add these two volumes together. The cube root of that volume, that is going to get me back to the same K because the K was cubed. So to go backwards, I cube root both sides. Now I can start cross multiplying. Or I can just put that into my calculator. And that's what I'm actually going to do. All right, so I'm going to have my square root of 58. And I'm going to divide that by my square root of 1,450. And that gives me 0.2. That was nice and easy, wasn't it? All right, so 0.2. And that is equal to the cube root of volume over the cube root of 1,250. And I'm going to go over here and say, okay, what is the cube root of 1,250? And since this is a very basic calculator and doesn't have cube roots, I'm going to do 1,250 to the power of 1/3, because that's the same thing as a cube root. Woohoo! All right, and I get this 10.77 long sort of thing. All right, so that's the cube root of 1,250. I'm going to multiply both sides by the cube root of 1,250. I'm here, cube root of 1,250. And go back to my little calculator here. So multiply by 0.2. Okay, so 2.15, etc. So approximately 2.1544 is equal to the cube root of v. So to solve for v, I'm going to cube both sides. All right, go back over to that 2.155. All right, to the power of 3. 10. Wasn't that nice and neat? But you weren't expecting that one. So now I know that the volume of my other little cube is 10. And what was the question? What is the sum of the volumes? My y is 1,250. My x is 10. That 10 looked really weird. Total is 1,260. Okay, I am hoping that made some kind of sense. This is an unusual problem. If that explanation didn't work for you, or you couldn't understand where I was coming from, let me know, and I'll take a crack at doing the way that they recommended for the SAT. I don't always agree with their methods. I don't always think they are the best, but you let me know if this was far too confusing and if their explanation made more sense, and I'll redo this one. But that's our last answer, 1,260. And you've reached the end of this. Congratulations. Hey guys, it's Alyssa, and if you're looking for more SAT or PSAT help, go to mathwithalyssa.com. There you can get over 25 hours of test prep. This is for both math and reading and writing, both sections. They also come with practice questions, downloadable study guides, and more. Links to everything are in the description down below. Leave me a comment if you have any questions about this video or any suggestions for future videos. I'm all ears. And if this video was helpful or useful in any way, please let the algorithm know about it. Like, share, comment, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye. And I think I slapped my leg because that's something you do. Why did I slap my leg? Why am I slapping my leg as I'm talking? Who knows? I don't know.